Bet you didn't see that coming, huh? All right, so the other day, hold on, let's do it like this. We talked about York peppermint patties, all right? We talked about, I'm not getting a good look here. We talked about input and output, all right? And we talked about how you input $1 and you get out 2 York peppermint patties. I'm gonna do a whole nother example right now about input and output, about the functions of spending money, okay? And that's it today. I mean, I'm gonna do this, I'm just gonna talk about this for a few minutes, and then I'm gonna real fast review slides from the other day. We're not learning anything today. All we're gonna do is keep applying the skills we've already learned and looking towards that quiz on Thursday and Friday and our week off. So, got a whole board filled out right here. Pizza is functions. Pizza is functions. Because a $5 pizza at Little Caesars is 8 slices. Did you know? I had to look it up. I wasn't sure how many slices. A $5 pizza at Little Caesars is 8 slices, which means that if you input $5 to that Little Caesars man's hands, he's going to output 8 slices to you. You input $5, he outputs 8 slices. $5 gets you 8 slices. All right? $5 is your input, 8 slices is your output. Now we talk about X and F of X. All right? X is the dollars, F of X is the slices. But it's just like real life. You give them $5, you get 8 slices. You input 5, you output 8. All right? And our domain on this chart just kind of keeps going in kind of a regular way. You input $10, you're going to get 16 slices. That makes sense. It's 2 pizzas. You input $20, takes you a second to think about it, but you output 32 slices. I left a couple blanks on here because these are questions we deal with in real life. All right, let's say you have $30. How many slices does that get you? You might already know the answer. Let's say instead that you need 72 slices. Well, how much money is that going to cost you? Those are 2 different questions, aren't they? So we have a domain of dollars. We have a range of slices. All right? Let's come over here and just review this sentence right here. F of 5 equals 8. All right? F of 5 equals 8. And that's just a math way. I want to be on the camera. I like being on the camera. That's just a math way to say $5 gets you 8 slices. $5 gets you 8 slices. That's what that equal sign stands for. Gets you. All right? $5 gets you 8 slices. F of 5 equals 8. So we have a couple questions down here related to what we asked over here. You got $30. How many slices do you get? F of 30 equals what? How many slices does $30 buy you? Just a little bit of math. 30 divided by 5, that's 6 pizzas. 6 times 8 is 48 slices. It's okay if you couldn't do that in your head. There's a lot of tricks about how to do that, but we don't have to worry about that right now. All right? But again, $30 buys you 6 pizzas, and 6 pizzas times 8 slices is 48 slices. Let's say instead you throw in a party and you need 72 slices. You got 24 hungry people coming over and they're each going to eat 3 slices, so you need 72 slices. Well, that's kind of just working backwards. 72 slices divided by 8 slices is 9 pizzas. 9 times 5 is $45. So you need $45. Let's read these sentences in English to wrap up our pizza is functions example. F of 30 equals 48. $30 buys you 48 slices. F of 45 equals 72. $45 buys you 72 slices. Anytime you give somebody money and they give you back something, all right, that's a function. Let's go over here real fast, all right? I'm wondering, I might switch the camera around. Let's see. So we have an example of a function, all right? And remember, this is just, we've been looking at this for the longest. And remember, we found the domain by listing those first x values. We found the range by listing those second y values. And it was a function because there was no repeat in the domain. Sounds familiar? Let's go on. Example of not a function, we did the exact same thing. All right, we listed the 3 coordinates and we listed the first x in the domain, the second y in the range, and this is not a function because it repeats in the domain. So if there's a repeat in the domain, it is not a function. It's still a relation. It's still all kinds of good things. It's just not a function. A repeat in the domain would be like this, just so you know why it's kind of bad. It'd be like if you went to Little Caesars one day and gave them $5 and they gave you 8 slices, and then you went the next day and you gave them $5 and they gave you 10 slices, and then you went back the next day and you gave them $5 and they gave you 4 slices. Like, if they kept changing the way they do things, that's not a good business model, all right? And so that's why functions matter to us, if that example makes any sense. And then the other thing we did is, nope, not that. Somebody the other day was making fun of this guy's smile. Kind of hurt my feelings. Hold on. Let me get it right. Not bad. Last but not least was this. All right, let me back up a lot. I'll get in his way. Let me see if I can get the whole thing at once. All right. And so we had 2 things going on. We had the thing on the left, which was reading off a table, and we had the thing on the right, which was using an equation. We're going to practice both of those things today. I'm not going to talk at super length about them right now because what I'm going to do is talk about them walking around the room. All right. So you're going to start by, where are we? Today we're going to start with graphs. All right, listing domain, listing range, no big deal. And then we're gonna move on to tables, listing domain, listing range, no big deal. Reading the table, we just did that with the pizza. And then we're gonna move on to the equations, which does get a little tougher, but I'm gonna walk around the room and talk about that and work that from the front, not right now. So there's our video for today. All right, I'm gonna get back to work. Whoa, oh, sorry. All right, I gotta go. Bye.